Good day to Prof. Today I'm going to present regarding the topic of fabrication testing of composite materials. So for introduction, composite materials have brought a remarkable advancement of the field of engineering and production. By combining a device components, these materials surpass the properties of traditional ones, revolutionizing the industry. So fabrication involves constructing composite structures unique using the technique like filament binding, hand layout, filtration, resin infusions, and breeding. Each technique has unique advantages and consideration, catering of specific requirement. The fabrication process includes stages such as layout, consolidation, curing, and post-processing, precise placement of fiber layers, and saturating with the materials along with compaction of removal of air gaps, result in strong bond. Occurring through the heat and pressure solidifies the composite structures, while post-processing achieves the desired dimensions and aesthetic. Testing plays a vital role in assessing composite materials. So mechanical, thermal, and electrical testing determine properties like strength, thermal behavior, and electrical characteristics. Destructive tests push material to extreme condition, while non-destructive tests ensure integrity and detect internal defect. Optimization through fabrication and testing brings numerous benefits, enhancing safety, efficiency, and sustainability across industries like automotive, aerospace, sport, and marine. Composite materials have found widespread application due to their exceptional properties. Thus, by leveraging fabrication and testing processes, we unlock the potential of composite driving technologies progress. So, for problem statement, fabricating glass fiber and cotton reinforcement composite present challenges in achieving uniform fiber distribution and alignment within the metric. Homogeneous mixing, fiber content conservation, and proper using method are critical factors. Understanding the fabrication process optimize fiber distribution and alignment, enhancing composite performance. Comparative analysis of mechanical properties like tensile strength, competence of elasticity, and elongation of a break is crucial. This analysis evaluates performance and applicability, aiding material selection for specific applications. Comparative studies highlight the uniques of characteristics and advantages of glass fiber and cotton reinforced composite. I think let's pass this time to Jackie.
For the project objective is understanding the fabrication process of glass fiber and cotton reformer polymer composite and compare the mechanical properties of the glass fiber and cotton reformer polymer composite. For the literature review, we have some methods to produce the composite material. In the first method is solid steps process. In the fabrication of metal matrix composite, the solid steps process has been essentially studied. The researchers has explored some methods such as hot isostatic pressing, spark plasma sintering, and powder metallurgy. The PM offer the cost effectiveness and the ability to fabricate complex geometries, and the SPS enable the production of high-density composite with excellent grain growth. For the HIP, on the other hand, efficiently eliminate defects and enhance the mechanical properties. These methods are obtained by testing the techniques such as tensile testing and sintering process analysis. And for the second method is stir casting process. One of the popular techniques for the producing metal matrix composites is the stir casting process. It involves mechanical stirring reform particles into a matrix mortar method. However, achieving proper particles weighting and uniform dispersion can be challenging. Researchers have used molding or casting to shape the meshes, and the resulting composite has been evaluated using various methods. And the third method is spread out method. The spread out method is a fabrication technique where a hand operated spray gas is used to apply the high pressure matrix and chop fiber performance, typically rolling gas. The matrix and reformer can be sprayed separately and cured at either a standard or evaluated temperature. Although the resulting products are voluminous and rich, the general process relative poor mechanical properties. And the fourth method is squeeze casting. The squeeze casting is a technique that combines forging and casting process in the fabrication of metal matrix composite. It involves the solidification of molten metal under pressure with depth reformers. The process includes preheating the metal, pouring the molten metal, applying pressure, and removing the composite material. Researchers had identified the important process parameters that affect the quality of viscous cast composite, although standardized control rules for these parameters are still lacking. And the last method is ultrasonic assist casting. The ultrasonic assist casting technique employs high-frequency mechanical compression to induce cavitations in the liquid. This cavitation process results in the growth and explosion of microfibers, facilitating uniform dispersion and disintegrations of particles along relation. In the variations of nanocomposite, USC has proven particularly effective in addressing agglomerations formation. The explosive collapse of bubbles during cavitation cycle generate high temperature, pressure, and rapid heating or cooling rate, with the third act in this integration process.
Next, the literature review for the mechanical properties of composite based on a previous testing. In the previous study, the mechanical properties of carbon and glass fiber reinforced epoxy hybrid polymer composites are measured by using tensile and hardness measurements. It shows that 60% carbon fiber composite demonstrate a 14.29% increase in the micro hardness as compared to 60% glass fiber reinforced composite under the vacuum bag process. It obtained that the 60% carbon fiber reinforced composite show 65.24% increase in the UTS as compared to 16% glass fiber reinforced composite. And a 38.01 increase in the UTS with that of a 30% glass fiber and 30% carbon reinforced hybrid composite. Please highlight the strength of carbon fiber compared to glass fiber. To benchmark the performance of glass fiber, next, we aim to compare it to the natural fiber, which is cotton reinforced in this project. Next. So for the methodology, we use in this project we use the hand lab technique as a versatile approach for composite fabrication. This is because the simplicity makes customization easier for the pouring the resin mixture, precision control, ideal for the small scale production, experimental flexibility, and lastly is because the unveiling composite performance. Next. So this the 9 material and apparatus that we use in this project. The first one is glass fiber as the for the fiber, and cotton wool as the natural fiber, the release agent, mold, balance scale, resin and hardener, trimming tools, hammer, and lastly we use the stick. Next. So for the procedure, first one, ensure that the workspace is clean and well ventilated. Where appropriate, attire according to the lab rules, including wearing shoes and a proper shirt. Second, differentiate between the fiber reinforced composite and natural composites. Cut glass fiber into a long pieces for the fiber reinforced composite and chop cotton wool into the short piece for the natural composite. The third one, using an electronic balance scale, measure 20 gram of resin and 10 gram of hardener according to the required ratio for the specific resin used. Number 4, in the mixing container, combine the measured amount of resin and hardener using a steering stick or any pedal to mix them together. Scrape the sides and bottom of the container to incorporate all the components, and then this mixture will serve as the matrix for the test sample. Step number 5, apply a release agent to the mold to prevent the composite from sticking. Place the cut glass fiber and cotton wool and the cotton wool into the mold. Number 6, pour the previously prepared resin hardener mixture into the mold, ensuring even distribution over the glass fiber and cotton wool. Stir the mixture gently to ensure the fiber are well coated and any excess air is released. Step number 7, close the mold using the appropriate method such as a plate and put a weight on top to prevent the leaking or outside contamination. Allow it to cure for the 1 to 2 days to harden. Number 8, after 1 to 2 days, gently tap the mold using a hammer to remove the test sample from the mold. Take care not to damage the composite during the molding. And the last step, use the trimming tool such as a scissors or knife or any rotary tool to trim any excess material from the test sample. Because we want to ensure a smooth edges and desired dimension for the final composite product.
Okay. So for the testing part is not conducted in the lab. Therefore, the past research will be used to discuss the possible outcome for tensile testing for both glass fiber and also cotton fiber reinforced epoxy. First study will focus on tensile strength for glass and also cotton fiber. The composites were prepared using hand layout process. Next, the test was carried out using a universal testing machine where composite specimens were placed in the grips where the fibers were pulled at a speed of 5 mm per minute until failure occurred. And the result of the tensile test then obtained and also compared. So based on the result, glass fiber composite possess higher tensile strength at 2,400 megapascal compared to cotton fiber at only 400 megapascal. This result showed that the comparison without considering the orientation of fibers, but corresponding with both reinforcement mechanical properties like Young's modulus, which indicates that resin with glass fiber reinforced will resist deformation better than resin with cotton fiber reinforced due to the higher Young's modulus. Next. So another finding worth to be discussed is on evaluation of compressive strength between recycled cotton fibers, RCF, and also glass fibers, GF, reinforced polyester. It is valid to relate to the study on tensile strength due to both are normal forces per area differ by only pulling and also pushing forces. So the total sample tested are 7 samples, 3 RCF and 3 glass fiber, and 1 control experiment sample of double layered cardboard. Since glass fibers are more crystalline and more rigid as compared to natural origin cellulosic fibers such as cotton, glass fiber-based composite offers higher stiffness and also compressional strength compared to cotton fiber-based composites. However, it is important to note that the glass fiber-based composite samples are developed with higher fiber volume fraction at 50% as compared to RCF-based composite samples at only 40%. Thus, the fiber mechanical properties and the fiber volume fraction have significant influence on the overall composite mechanical performance. Then I will pass to my friend AZIZUL.
So this is the last result, which is tensile, impact, and fiber length properties of injection molded short and long glass fiber reinforced polyamide sheets composites. So since our specimen fabrication used 2 types of fiber orientations, tensile tests on injection molded short and long glass fiber reinforced polyamide give some insight on the relationship between fiber orientation and tensile strength of fiber reinforced composite. Long fiber composite LFC possesses higher tensile strength compared to short fiber composite SFC across the fiber volume fraction. It is due to the existence of longer fiber can restrict the matrix movement more than short fiber even at low volume fraction. To conclude, the specimen of continuous and aligned glass fiber reinforced epoxy will yield higher mechanical properties, specifically on tensile strength than discontinuous aligned cotton fiber reinforced epoxy. Next, I will conclude our project. So objectives are achieved after a successful fabrication process and comparison study. In this project, we are exposed to the issues and problems plus challenges before, during, and after fabrication process of composite materials. These problems have emphasizes on the needs to reduce fabrication errors for better performance, such as in our project, there is a void in our specimen. We also have the chance to observe and feel the texture of the produced composites by hand layout fabrication process. And we are able to understand the fundamentals of composite material and identify its mechanical properties. Lastly, a comparison of the performance of glass fiber and cotton reinforced polymer composite is made. That's all from us. Thank you.